Hey, sixth graders, we're going to go through algebra review. So this is everything you need to know about algebra in a nutshell, condensed down into one page. So we're just going to do a few examples of each just to refresh how we, solve various types of algebraic problems. So let's start out easy with one-step equations. The way we solve them is we use the inverse operations of whatever operation is being used. So the inverse operation of addition is subtraction. The inverse operation of subtraction is addition. Multiplication, its opposite is division. And the opposite of division is multiplication. So we're going to use the opposite to isolate the variable. Now, please be careful and keep your integer rules in mind, because that's really how I bumped it up and made it 7th grade level content. So let's go ahead and set up our algebra T. We're going to add 5 to both sides because we originally started out with subtracting by 5. So we're going to add 5 to both sides. And we get negative 2 equals k. We can check our work by plugging back in. And is it true that negative 2 minus 5 is equal to negative 7? But we would need to KCC that. So it would be negative 2 plus negative 5, which is negative 7. Terrific. So we can check our work. Please don't forget that. This one we're going to subtract 5. Now we need to KCC here. You got to be really careful. That's negative 7 minus negative 5. So that's going to be the same thing as plus a negative. So that is negative 12 is equal to k. And again, you can check your work by plugging back in. We're going to multiply both sides by 5 to undo dividing by 5. We get k equals negative 35. And lastly, we divide both sides by 5, and we get k is equal to negative 2. Okay, so that's pretty simple. Let's take a look at some more challenging scenarios. What happens if the coefficient is a fraction? A lot of kids kind of get nervous, start freaking out when they see fractions. Have no fear, the reciprocal is here. So what we're going to do is we're going to multiply both sides of the equation by the reciprocal of that coefficient, because dividing by a fraction is indeed the same thing as multiplying by the reciprocal. So technically here we have 1/3 times m. Technically I would divide by 1/3, but dividing by 1/3 is the same thing as multiplying by 3/1. So I'm just right off the bat going to multiply by 3/1. 3 times 1/3, boop, boop, it all cancels out. So I'm left with m equals 90. And that is true, that 1/3 of 90 is 30. So here I'm going to multiply by 4/3. Multiply by 4/3. Because that will cancel everything out. You're left with y is equal to, let's say I can cross cancel 1 and negative 5. Negative 5 times 4 is negative 20. Again, you can plug back in, make sure that 3/4 of negative 20 is negative 15, which it indeed is. And lastly, we got this guy. Let's multiply by 5/2. That would give us 10/10, which is just 1, so all of that cancels out. Need to multiply this side by 5/2. We can cross cancel again. 5 times negative 5 is negative 25 equals p. Okay, let's take a look at two-step equations, some basic two-step equations. We're going to solve just like we do with one step using our inverse operations. But what's important is the order in which we undo things is going to be SADMEP, the reverse order of operations. So we need to get rid of subtraction and addition first. So here I've got negative 4h plus 10 equals 2. I need to subtract 10 from both sides. Negative 8 equals negative 4h. Divide by negative 4. H is equal to 2. And you can plug back in, and it is true that negative 4 times 2, which is negative 8. Negative 8 plus 10 is indeed positive 2. 7y plus 6 is equal to negative 15. I'm going to subtract 6 from both sides first. This is a KCC situation, so that's the same thing as plus and negative. So it's going to be negative 21 equals 7y. Divided by 7. Negative 3 equals y. And lastly, we've got add 8 to both sides. We get 3 is equal to 3/4 p. Multiply by 4/3. Multiply by that reciprocal. And p is equal to 4. All right, let's take a look at more challenging two-step equations. So two-step equations with grouping. We use parentheses and fraction bars to represent groups in equations. Recall that we use SADMEP to tell us what order to undo operations. So we undo the parentheses and the grouping last. So I'm going to get rid of the stuff inside of the parentheses last, which means I'm going to get rid of what's outside of it first. I'm multiplying by 4, so I'm going to divide by 4 to undo multiplying by 4. The 4's cancel out. You get x plus 13 equals 2. Subtract 13. And we get that x equals negative 11. Over here, I'm going to divide by 9 first. I get x plus 8 equals 9. Subtract 8. Oops, sorry, 2. Goodness, subtract 8. And we get x equals negative 6. Now with these ones, I'm going to go ahead and I'm going to get rid of the parentheses last, which means I need to undo the dividing by 5. How do I undo dividing by 5? By multiplying by 5. So those 5's cancel out. You get n minus 10 is equal to 20. Add 10 to both sides. N equals 30. And lastly, I'm going to multiply this by 10 and by 10. So those 10's cancel out. We get y plus 8 equals negative 90. Subtract 8. That's going to be a KCC situation. So you get y equals plus negative 8, negative 98. Now, I know I'm going through this fast. I don't expect you to, be able to work through it as quickly as I do. But, that's the process. Solving with variables on both sides, you must get the variables to one side and the numbers to the other side. So you're isolating the variables. You do so by using inverse operations. Notice how inverse operations keeps coming up. That is the baseline. That is like the heartbeat of algebra is inverse operations. So the first thing I'm going to do is I'm going to go ahead and combine these like terms. Negative 3p's plus 2p's, that's negative 1p plus 10 equals 5p minus 2. I'm going to go ahead and bring my p's over to the right-hand side by adding a p because a negative 1 and a positive 1 cancel out. So I'm left with 10 equals 6p minus 2. Now I've got a pretty easy peasy two-step equation. And we get that p equals 2. And you can plug p into each one of those and make sure you get a true statement. So here I'm going to multiply both sides by 3 first. And I get 6 plus 3t equals 6t. And now I'm going to subtract 3 t's from that side to bring them all over to the same side. So I get 6 is equal to 3t divided by 3. T also equals 2 over here. And lastly, we talked about solving proportions where we use the cross product. You can use equivalent fraction route as well, but I'm just going to jump into cross product. And then we can use our distributive property and algebra skills to solve for the variable. So I'm going to go ahead and use my cross product, and I get 36 equals 4 times x plus 2. It's the whole thing. I'm going to go ahead and divide by 4 first. So that's 9 is equal to x plus 2, which means x is equal to 7. So we subtract 2 from both sides. And lastly, I'm going to go ahead and jump right in with my cross product. I get 36 equals 4 times y minus 3. Divide both sides by 4. 9 equals y minus 3. Add 3. 12 equals y in this last example. I would check your study guide for your semester exam study guide has more problems like these. I would go back to the study guide for unit 8 to continue practicing your skills. You can just completely retake the study guides. I think that's a great way to study, and you can ask me questions tomorrow when I return.